Okay, so I think we can start. First, let me share the lesson that today we will cover. Well, today and tomorrow because it's a long lesson. This is the link of the lesson, and also for exercises. Well, the exercises are in the link that uh, I will copy paste them there in this share document. Um, okay, just to put this a little bit into context, yesterday we were talking about data cleaning when we have a data set that we can receive from other researchers or other colleagues, or we download it from internet. We can play or adapt that data set to our needs. We can add new columns, we can remove columns that are not needed, we can remove rows that maybe have some missing data. And yesterday we show how to do that using software like Excel, LibreOffice, OpenOffice, and also using if we have a large data set using OpenRefine. Today we learn a programming language that is called R, and this programming language will be used to open these data sets and do work with them, do some statistics. Also, we can do some plotting. Today we will begin with the basics of the language, how to use arrays, the data types that we have. Later we will open a data set and we will see columns, how we can select part of this data set. And tomorrow we will learn more about plotting, and also about we will learn the concept of queries. We have a data set, and we can let's say ask questions and get the answers. So, well, this is a small introduction. So for today we will need R, that is let's say the software that will interpret R. Also, we will use RStudio, that is a IDE. This I think is called Integration Development Environment. That is very useful because you will see that have a window so for some to write some text. You have also the console to execute commands, environment, files, etc. And also we will need some packages that in case that we install them later. Okay, so what I will do is first I will let me share. I'll give a small introduction about what R is. Let me share the screen. Before we start. So again, this is motivation why we are learning R. I go through these points so that R doesn't involve lots of pointing and clicking, and that's a good thing. This is what the same that I explained yesterday, that when we use a graphical user interface, it's good, it's easier because you with the mouse you can do a lot of operations. But in terms of not the best because when you want to tell someone else, please follow these steps, it's better to, in this case, to send an R script and say, okay, um, the same R script, you can have some comments and you can read through, and you all people who execute that script will get the same result, rather than please click in the top left, there is a button that is open. All this stuff is less reproducible. Also, this said here, this interdisciplinary, extensive. The good thing with R that there are many packages that many libraries that we can use for whatever we want. Produce high quality graphics. So for this is important if you want to publish something on a conference, a journal. You can produce good plots. I remember using past GNU plot, or well, also this very popular that you might use Python, but just to let you know that R also can produce high quality graphics. Also, because R is used by a lot of people, you have a larger community. In case that you have any doubt or anything, you write the question on a search engine or Stack Overflow or Studio community, and you get an answer. Also, the thing is that R is free and is also open source and cross-platform. Doesn't matter if you use Windows, Linux, or Mac, you will have the access uh, to R, and also RStudio. RStudio is the IDE that we will use today. That is quite useful, and that has two versions. Has a free version and also has a commercial version. Today we will use the free version. Is good enough for what we plan to do. Okay, so what I will do is I will stop sharing this theory, and I will start sharing the window of RStudio. Let me share application. Studio. In case you have any questions, please feel free to let me know or write them in the chat. Today we have William with us, that is a colleague of mine and will be a helper for today's lesson. So please feel free to ask as many questions as you may have. So this is I'm sharing the RStudio interface. You may notice the font is very small, but I will make this bigger. So we have a three different. The window is divided into three. We have a left-hand side. We have the console where we will write the R commands or R instructions or whatever. Here, top right, we have the environment. This is useful because when we create a new object, we will see them there. So here is, let's say, the memory that are, or the data that are memory. Now they said that the environment is empty because we don't have anything memory. We just open and we didn't load anything. And here we have files. What I will do for this, I will create a project, and we will work using this project. So in order to create a project, I need to click on File, New Project, and you get a new window. So what we will do is we will create a new directory. And they ask us about the project type, so we will create a new project. And the directory name, we can use the same name that is used in the documentation if you want, or you can choose the name that you prefer. Doesn't matter. I will use data carpentry. And also you can save the project. I will save it in this document. So when I click in create a project, you see that again I have the console here, have global the environment, that this is the objects that we have in memory, and here we have a files that in home data carpentry we have this file that is the some metadata of the project. And for today and tomorrow we will need three folders. We will create the folders in order to have things separated. I have things like with a better sorted. So we will create the three ones. The first one will be data underscore row. Here we will data. We will create another folder that is called data. That here we will save the ones that we clean and we edit the data. We will save a copy there. And also we will create a folder called fig, that this is for the figures that we will create tomorrow. So now my project contains three folders. Also it's recommended in the documentation that now the environment is empty, but if we work with large data sets, or ask you if you want to save that into disk. It's recommended not to do that because imagine that you're working with a data set that could be gigabytes. So you are saving that in memory, that memory into disk. The documentation that said that is not like the best. So the way of disabling that is in tools. If you go to global options, if you want, you need to untick this option under a workspace that says restore our data into workspace and startup. Also, you have a save workspace to our data that you can choose always, ask, or never. I put never. I follow the advice of the documentation, and you can click there. Yeah, okay. If in case that I'm going fast or slow, tell me that in the chat, because having this online, I'm not sure. I cannot see your faces, and I cannot see if I'm going too fast or too slow. So please feel free to tell me that in the chat. Also, we are a small classroom, so that's I think it's easier for talk more or have a more interaction. Okay, so two things before we start writing our code. We have you see here that that is the right bottom. We have several tabs. One of them is help. So here, in case that you want, well, you have all of this help, but you have a search box here. So in case that you want to search with the meaning of you get here all of these functions. and you get the some the R documentation, the entry for the arithmetic mean. So it tells you the description, the usage, argument, value. You have all of these. Uh, Also, what I like of the R documentation that you see at the bottom, you have some samples, and you can see our code here. Now you may not understand, but you will know what all of this means. Also, it's useful in case that something is not working or you need some help. That when you write the question, you include the information of your R distribution. I mean, the version that you have installed, packages that you have loaded, etc. So now we will use our first our function that is called session info. If we use RStudio, at the moment that I start typing the name of the function, I get some pop-up with the complete name of the function, and also I get some info of that function. In that case, they said print version information about R, the OS, and the attach of loaded packages. So this is useful for the person who answered your question to know more if it's a problem with the license, not a license, problem with the version, a problem with the system, whatever. So let's execute that because it's a function. We need this is the finishing bracket. A thing here with this programming language is that we don't need in other programming language like for instance C, you need a semicolon at the end of the line, but this is not the case in R. So once that we write that, we press enter. Is that so? Well, the version has been installed pretty recently. So we have the R version is 4.2.1. That was well, we have the time that was released. That was 23rd of June. Platform that we are using, that is 64-bit, running under Windows 10, 64 bits, and also tells you some environment that are defined, base packages that we have loaded, etc. So this is useful to debug issues in case that something is not working properly. And what you will find in the documentation, there are many other resources in case that you need to access them. Okay, so let's start. So the console could be used as a big, like a big calculator. If you type, for instance, 3 plus 5, enter, you get the answer. This 8. You can divide. So it's like a big calculator. The thing is, what we will start using here are in the documentation. You will find that is mentioned variables, but also objects are in for today, tomorrow. You can use the either objects or variables. But if you investigate a little bit further, you will see that there are differences on the. But I will not. Maybe I explain later the difference. But on our, what we know as a variable is called an object because okay, the difference if you go to other programming languages, variables means only they talk only about data, so you refer only to the data. while an object, you can have some functions associated with that variable. That's why it's called an object, because it's like a data plus some features, functionality. But feel free to forget that. It's not. We will not go deeper into that. Okay, talking about objects or variables, we can create a variable that could be the weight in kilograms. So to create a variable, we can. Okay, what I will do, rather than writing things on the console, you can do two things. You can either write it here straight to the console, but also you can create a new R script. So to create the R script is a file, new file, R script. Also, if you want to use the keyboard, you can use Control Shift N, and you have a text file. Comment. Comment starts with the hash or hashtag symbol. You can write this is a variable in R, and you can define your variable, that is weight underscore kg, kilograms, and designation. This is also an important point in R. Standard, you use an arrow. The arrow bright less than equal and a hyphen. You can do that, or also you can use if you use the keyboard Alt minus, and you get this arrow. This is the way of assigning values to variables or objects. So I will assign the value 55, and if we press enter here, we go into a new line of the document that we are writing. In case that you want to execute this line, you need to press Control Enter, and you see on the bottom of my screen, you see that this R command has been, or this assignment has been executed. And also you will find, if you check the environment top right, you will see that we have a value. We have a weight in kilograms. We have a 55. So this is the what we have in main memory. Also, you will find in some other documents, scripts, that some people use equal to assign a value to a. You can write something like oops, back here. Is it? I will make this a little bit bigger. Maybe tomorrow. Yeah, should be okay. Should be better now. For kilograms, you can use equal 55, and it will work. The problem of using problem. For instance, in this case is the same. If we do this assignment inside a function, it will be different. I will explain that later. But the standard or what is like recommended is to use the assignment using an arrow. What else? Also, when we do an assignment, we don't get an output on the. So if we want to get an output, we can write the assignment between brackets. And if I execute that, you will see that you get the output that is 55. Because, okay, here we are assigning a number, but imagine that you are assigning a arithmetic operation or something like that, and you, I don't know, you are interested on seeing the output for debug purposes. You can get that using brackets. Okay, so what we will do is now we will create a new well, with this variable we can use them as a number. We can multiply 2.2 multiply by weight. Also, I'm getting this menu. If you press tab, you get well, here this is the variable that we have defined in memory, and also here we have functions that we can use. But we'll write weight kilograms, and if I execute that, I get the answer is well 121. In case that I want to save that value, I could define a new variable called weight underscore pounds LB and assign the oops I press okay yeah I press control minus rather than alt and assign the operation of 2.2 multiplied by weight kilograms. If I execute that, we see now that in our environment I have a new variable weight in pounds and the value is 121. Also, we have here we have the history of all of the commands that are connection, tutorial. Okay, so we have two variables, weight in kilograms, weight in pounds. Now I will change the weight of kilograms rather than 55. I will update it and I will update it to 10. And now weight in kilograms is 10, sorry, 100. So, it's 100. Do you think that the weight in pounds have changed? This is a question for you. So please let me know in the chat if you have if you think that the weight in pounds have changed or not. After updating the weight in kilograms. So exactly, yeah, that's you're right. It doesn't change. Why? Because as you said, when we calculated the weight in pounds, well, also I will we can see that in the environment. You see that the weight in kilograms is 100, and the weight in pounds still is 121. Calculate the weight in pounds, we use the value that the weight in kilograms has in that moment. In that moment was 55, so we got that value. If you update later the weight in kilograms, doesn't matter. You update that variable, but you the other one is not. There is no link between variables. So you are right. It's not updated. This is important because sometimes um, confusion, and you may think that is is updated, but yeah, that's you are right, that is not updated. Okay, so we learned how to use variables, so we will move on and we will use functions. Function is pretty simple. So for instance, we have the function sample is the square root, that is sqrt, and the values are in the values that the function receive are in brackets. They could be some functions like the previous one that we used that was called session info, that you don't need to send any values. So the square bracket, so not the square, the brackets they are empty. You don't need to put anything. But here, for instance, for the square root, you need to specify the or what the number, which number do you need a square root. So you say to execute that control enter, and we get the answer on the bottom that is 3.162278. There are other functions that could be could have a one or more parameters. There is another function that is called round. You can say, for instance, a number 3.40. So you get that the output of this function is 3. Also, you can give the output on another function. So you can use a round square root of 10. So you execute that again, well, you get 3 because as you can see, the output, the previous output was 3.16. So you can do something like that. This is useful in case that you want to know more about the function. Maybe don't remember the arguments that this function has. There is another function that is called arcs that tells you, well, here you can see in yellow, tells you displays the argument names and corresponding default names of a function of a primitive. So here is arcs the round. Oops. So if I execute that, as you can see in the output, the function has two arguments. The first one is called x, that this is the number that you want to round, and the second one is digits. Digits is the decimal positions that we will have after the point of yeah, I would say comma, but no, comma is used in other languages. In English is a point. So we can do for instance, we can do round. The first argument will be 3.1416, and the second argument will be the positions that we want. For instance, we want 2 digits. So if we execute that, you see that the output is 3.14. Another, you see also that in the output of arcs, you have two arguments. You have x and digits. Why? Because if you want, you can swap or you can change the order of the arguments. If you write round digits equal to x equal 3.1416. So if you execute that, you will get the same output. You may notice here that I'm using rather than the assignation. Why? Because in this context, what I'm defining the value of the arguments that I send. If I use an arrow there, a new variable called digits will be created, and a variable called x will be created. So in this context, the advice is better to use equal to give values to the arguments. That's the main difference of this, of using equal, of using an arrow. Any questions so far? If not, we will continue. We have seen. If you have any questions, please feel free to interrupt me. No need to wait until the end. That's a good question, and that's the good thing of like using this that we can play around and see what happens. So if we use the arrow there, yeah, let's use it. So before we use the equal, so let's use the arrow. So it's a round. So we use digits 2 and x 3.1416. So if I execute that, you will see if you check the environment, I have created two new variables, digits and x. So the thing, this also happens in other, I don't remember now, but I have seen that in other program. I know in other programming languages you can define the variable. No, forget about it. Here you are doing two things at the same time. You define the two variables. You define digits and x. Send these variables to the. Well, okay, that's a good point. If you see the output rather than 3.14 is 2. Why? Because actually what you are sending here is this. You are sending the first argument or the first value that is 2 and the second value that is 3. So you cannot don't use the name of the arguments any longer. Here you define a variable and you set the value to that. I'm not sure if it's clear the difference. Maybe it could be a little bit confusing. I'm happy to repeat again. I'm not sure if that's clear or not. So this is mainly the difference with the when you use equal, you can play with the arguments. The arrow, you create a new variable. Okay, I know what you mean. The problem is, it's a little bit tricky because I think the second one digits is an integer, so they don't care about the decimal. So it's like what you're actually sending is around 2 3, because I think the decimal part is discarded because the argument, the second argument of the digits is integer, is not a floating point, is not a real. So that's why you don't get true. Thanks for the question. Again, any other questions, please let me know. Let's continue. Okay, we have a play around with functions, variables, and now let's move on and we will play with the vectors. So vector is a data type that you may know is a list of several elements. Here, it's important in R, all elements must be the same, must be from the same type. So the integer, real, character. I have seen the thing in Python. You can have vectors from different types, but not in R. R, all elements are from the same type. So we can define over, okay, let's create a comment, vectors. So we can define a vector of weight, that is a weight underscore G, designation. And here to create a list vector, we use the function C. C, bracket, and here I put the elements that I want to, so I can write 50, 65, 72, 83, for instance. If I execute that, you will see now in the, again in the environment, we have a new variable that is called, that is the, actually the vector that we have created. In case that you only work with a console and you don't have a, let's say you don't have RStudio, because here in RStudio you can see the elements, you can have more information having environment. But if not, there are some functions where you can get length, content, type, etc. So okay, let's create, this is a vector of a weight, and also we can create a vector of, let's say, animals. Again, C, and the animal could be a mouse, rat, and a dog. So again, here I have a vector. In this case, we will save strings rather than numbers. So if we execute that, we see that we have a new element in memory. Okay, I have two vectors, but I wonder how many elements have these two vectors. So we can use the function length. Oops. Length weight. So that we have 4, and also I can have the length of animals. That the output is 3, so there are three elements. Also, I can get the type, that is a class. So the class is a numeric, and the class of animals is a character. So I also are in some documentation you will find that rather than variables they use objects, because well, now you can imagine here they use class object. So they use that like a nomenclature to also have all of this information at the same time. Like you don't want to like write all of these functions. You can use the function str, and the parameter will be the the vector that and the output we see that is a numeric, the first element, or the first element, sorry, the in the output, the first thing that we see is the type or the class that is a num, numeric. We see that we have and we see also the value of this element, that is 50, 65, 72, 83. Okay, how can I add an element to the vector? In R is very simple. I'm not sure if you have used other languages like I don't know. During my degree, I remember using C, and to add a new element to a vector was more trickier because you need to pay attention if it's clear, but it's way more difficult. With R, it's pretty simple. How we can add an element? So we write the name of the vector that we want to use, the assignation, the arrow, and then we create a new vector that the contents are the vector itself and the new element that they want to add is we 90. So if I execute that, you will see if I print the vector, you will see that now we have a new element. So we have 5 elements rather than 4, and you see that the last one is the one that we add, a 90. So we can add elements at the end of the vector, and also we can add elements at the beginning of the vector. So we can use okay, well, let me write better in this file. Wait arrow C. So to add elements at the beginning, you can do 30 on the vector itself. So if I just execute that, Control Enter, and again you print the vector, you will see that now we have 6 elements. The first one is 30, and the one is 90. So regarding that is a okay. That is here a small exercise that I think we can do and we can understand better. We have seen so far vectors or numeric character, but also there are other types. Could be logical, so we can save true and false elements. We can use integer to specify an integer in R. You need to add imagine that you have 2, so you need to add at the end an L in order to specify, okay, I want you to save that element as an integer. We have a complex for complex numbers, and we have a row bit string. That's the case that you want to save a photography or you want to save a binary file for some reason. But we will use this in this workshop. We will work with numbers, characters, etc. Okay, so the exercise, maybe it's easier if I copy that. Okay, so it's not. There is a question that is, can we change the values in the vectors? We'll see. Is what I have explained is to get access to a given value. You see, if I write the name of the vector and I execute it, I get the whole vector. But how can I get the... Okay, let's explain this. How can I get, for instance, the vector? So to get that is a wait. Oops, wait. I'm using a square bracket. We can get the first element. So square brackets, and in R, how will you get the first element? You will use 0 or 1 to get the first element of the vector. Or in the document, I usually use array. That's why I'm like all the time that I wanted to say array rather than vector. But yeah, just to follow the names that in the documentation are used. But yeah, I don't know why I always use array. It's same. So yeah, that's the that's the thing. If here the R is from the family of types or programming languages could be divided in when you index, you use 0 for the first element, as you said, is Python, C, C++, in Java as well. But if we use languages like Fortran or R, the first element is 1 because the idea of these languages is like use natural numbers, say human readable. So if you have one element, the first element is number 1, so you use 1. In C, C++, Python, you use 0 because for the computer it's easier. Now, for some arithmetic operations and when you do some bit accessing, now it's a little bit, if you use the first element that is a 0 for arithmetics, internal arithmetics in the processor, language, compiler, etc., is way easier. That's sometimes the issue when you change between programming languages. You can have that. Don't know. You may use 1, meaning that you want to get the first element. For instance, if you do that in C, you get the second element. So here we need to use 1. The first element that is 30. I don't know what is the output if we use 0. That's the good thing of this, that in case that you have any equations of or what if, you can execute it on. Okay, I think yeah. In this case, we get the type of the, but well, it's not. Also, let me check my one. Oops, it's control. That makes sense. Yeah, there is a thanks, William. There is a comment in the chat that says that languages that are more, let's say, math based, like Fortran, thing, yeah, name for formula translation, or R, that is heavily based for statistics and uh, handling numbers. They use one rather than zero. Languages like C, C++, Java, Python, yeah, they have a well, actually, I think yeah, most of them are basing, let's say, are C-like languages, and they still use zero as an index. Yeah, that makes sense. For instance, also for indexing is if we use -1 means give me all the elements, but minus the first one. So you get the output, you get 50, 65, 72, 83, 90, but you don't get the first one. So this is regarding indexing. Also, you can get well, now that we are talking about indexing, you can get a element. You can say give me the first and second element, or the first, second, and third element. So to do that, you use a square bracket, and you can use 1 colon 3. So this is a short, this is a kind of iterator that tells you give me the first and the second element, but don't give me the well. Okay, the third element. So give me all the elements from the first one and up to the third element. So you get 30, 50, and 65. Okay, so the exercise that I will copy that in the, not sure if in the chat will work. Okay, so it's a tiny exercise. Is you have 4 vectors, and you see that these vectors have different um, elements from different types. So you have a number. For instance, in the first one, you have a number, 3 numbers, and a character. The second one, you have 3 numbers and a logical. The third one, you have strings, logical. So just execute them and check what the elements are, or if there is an error or what that happens. I'll give you a few minutes and just let me know when you're done with the exercise, and we can continue. Okay, so we continue and see the solution or see the output of the. Okay, so we have these 4 vectors. The first one is have a numbers and a character. Well, yeah, character string. So if we execute that, you may see if we write str num underscore char, you will see that our elements have been converted to a string. Normally, R, what it does is when you have a different element, or yeah, elements from different types. You try to choose the type that you will be able to still keep the element. Okay, if instead of characters, if we use numbers, there is no way to represent a. We are talking about hexadecimal. Uh, yes, a makes sense, but in this case, if we are talking about uh, numbers in the decimal, a cannot be represented. But 1, 2, or 3, you can represent them using a character. So that's why this is chosen. For numbers and logical, for instance, in sorry for like mixing programming languages, that doesn't exist true and false. What you use is 0 for false and 1 for true in case that you need to use logicals. Here, we will execute that num logical. Where if we go to the environment, you will see that the last one, the last element that is uh, true, is converted to 1. False if that still keeps the. So yeah, the conversion is true is equal 1 and false is equal 0. Because the other numbers 2 and 3, to save them as logicals, it's not able. So you need to choose like the type that is like a more that can define all the elements. And again, child logical, I imagine that this will be converted to exactly string. And tricky, you have a, well, okay, you have a number defined as a string, but R doesn't check the contents of the string. You check that this is a string. So when you execute that, everything is converted to characters. My advice here, well, this is because we are learning the language and we are playing around. What if we do this? What if we do try not to define a vector or array? Try to define or well, use all elements of the same type, because when you use elements from different type, yeah, you okay, you can guess. Okay, I will get strings, but yeah, I'm not sure exactly also about the. Oh, I don't know. I always use when I have a vector, so I always use same type. I never had the need to use different types. This is okay. Let me check what's next. Next is okay, getting elements of the vectors that we have seen how to get the first element, how to get um, other elements. The good thing of R that you can play a lot with the indexing. So for instance, we have the animals. We'll print again because I don't remember. Okay, we have a mouse, rat, dog. And imagine that I want, rather than the second and third element, I want the third element first and then the second element. This is possible if we have animals, square brackets, and here I define a vector with the positions. So I want first the third position and then the second one. So you see the output is a dog and then a rat. So you can choose the order or of the elements that you get. Also, you can repeat elements. I don't know if you want animals for some reason. If you want, let's say 3 dogs and a rat, you can say 3, 3, 3, 2, and you get the output. You get the element number 3 repeated 3 times, and then the second element, number 2. Also, it's interesting. This is regarding indices, but also we can play with the logical. What does it mean? Okay, let's keep using animals, square brackets. So I can define a vector to say, okay, I don't want the first element, I want the second and the third element. You can use false, so I don't want the first element. I want the second one, sorry, true, and the third element, yes, so true. If I execute that, I get the second element, rat and dog. So I can also sometimes, yeah, this sometimes you will find useful that you can define these the elements that you get the output like this. If we move to let's use now the vector of a weight. Let's see the content 30, 50. So I want the weights that are greater than 50. So what I can do is inside in the square bracket I can write a condition. So the condition is the weight must be larger than 50. As you see, the output is 65. So you get all elements that are larger than 50. Because how does it work? If you only this weight larger than 50, you will get a vector. The output is a vector that is false, false, true, true, true. So you get if the element is greater than 50, you get a true. If is equal or slower or lower, you get a false. So this vector is the input of this. When you index the vector, you can also combine. You use ampersand to use and or the vertical bar for or, so you can get elements, square brackets. You can get elements, oops, that are larger than 30, and so we weights that are smaller than 50. Well, we get here numeric 0 because in our vector we don't have elements that are larger than 30 and smaller than 50. Let's use the same but smaller than 70. Are larger than 30 and smaller than 70 could be 50 and, well, we get a 50 and 65. Also, you can, when you use strings, you can also, compare the animals. I want the are equal to a rat, for instance. So you get the output is a rat. Okay, here maybe it's not this makes sense when you have a vector and some elements are repeated in this vector. So if we want to add a new element to animals, so we have if we print animals, we get mouse a new element that will be a rat. How was to add a new element was animals, nation, create a vector that is animals and rat. So if I execute that, I print again animals. So we see that you see that we have now 4 elements: mouse, rat, dog, rat. This. So if I execute that, I get these the two elements that are. So this is regarding getting a part of the vectors. You can either use an index or you can use conditionals on that. Not sure if there are any questions. Let me check in the chat. Okay, if not, last part or the last thing before going for a break is okay. See that there is a. So how many? That's a good question. How many elements do we have? We have a vector, and I want to check the elements of how many times a rat appears. So what comes to my mind? Maybe there is a function or there is a better way, but let's say the first solution that comes to my mind is you can use length here. So length, you say the animals that are equal to rat, so you get a vector and you calculate the length. So I think it's because it's like this. With length, I always confuse t. And you get okay. Put this. This is a way. I imagine that maybe better ways, but this is the one that comes to my mind right now. Cool. So, okay, now before going for a break, the last part, yesterday we were talking about not defined for some reason. Imagine yesterday that we were talking about observations of several animals and we have the weight. Imagine that for some reason the weight is broken or whatever, and you don't have you cannot save you can save all of the other variables of this observation, but you cannot save the weight. So one way to save, let's say, an undefined element in R, well, we use a blank. Here we will use NA. So I think this is better if we write here an example. Missing data. Okay, I think you can see yes. So we will save the height vector 2, 4, 4, and A, because we don't know the height, and 6. So if we execute that, if you go to the environment, you will find the heights are here, a numeric, and you will find that you have 5 elements. 2, 4, 4, and A, and 6. So, for instance, I want the average of height. So I can average the mean. The problem here is that I cannot get the average because I have an element that I don't know, that is NA. So the function says, sorry, I cannot tell you the average because I will need to know that element. And this is the same with the maximum of heights. Here what we need to do is we need to say, okay, give me the maximum, give me the average, and ignore the elements that you don't know. What is the way to do that? You do mean, you send the vector height, and then you say na.rm equal true. This is remove the elements that we don't know. If that, you get the output is 4, and if for max, we can execute the same height na.rm equal true, and we get the maximum is 6, the maximum value. Also, for curiosity, you want to if you write args max, you set by default, and a.rm is false. So you don't need to define that in the. You can always where these 3 dots are the elements that in our case is a vector what we send. Well, here also this is what at the beginning of the lesson what I search. You can have the arithmetic. You can search mean here, and you see the arguments as well. The trim value. So it's quite. I like the documentation of R. It gives you a lot of information. And okay, this is when we use a function, because this function has this argument, and you can see that ignore the elements that are not defined. There are other ways to do that, and you can use them. It's up to you, depending on the. So you want to, if we print a height, we get the elements with the NA, but imagine that we want to get rid of. So if you remember, previously we have, well, we can use the function that is.na and height. That false, 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 true. So here you can, well, now you can imagine what I will do next. So height and the indexing, I will use that function is.na height. The problem is here I get the opposite. I get all elements that are NA. So I need to use the exclamation symbol to use the negation of with the but if something is false, it's converted to true and the other way around. So if I execute that, you see that the output is 2446. The element that is not defined is gone. You can also use na.omit height, and the output is well, you get more stuff, but mainly you get the vector without the na. And also the third option, you can use. I'm telling all of these options just for in case that you see them in the future in some codes, just to that you know that there are several options and you can use. It's up to you. My preference or what I feel that is more is to use the first one is more. I would say more but readable. For me, it's more is because you see height, square bracket, and a. So I personally I use the first one, but you can use the one that you prefer. The third option is height, and you use a function complete.cases of height. And again, this returns a vector that is true or false. So, well, you can see we execute that separated. Again, you get the one is more elegant. Up to you. Is the one that don't know why the thing is the second one. The output are more elements. I don't know what. Yeah, not sure about. Don't know. Personally, I would use either the first or the third one. But yeah, this is up to you. Cool. Okay, so we are morning break. So from now until 11:30. After the break, we will have a tiny exercise to play around with this, what we have seen so far. We will load the CSV file and we will start playing more with more complex data structures. So have a nice break and see you at 11:30. Thanks. Hello everyone, welcome back. Hope that you had a nice break. We will start with an exercise that is, I copy the exercise here. So if you go to the bottom of the page, actually I will share it. Maybe it's easier. Oh well, okay, let me. Moment. No. Okay. Yeah, I'm loading the exercise to share it here on the screen. Okay, so this is the exercise that I would like to ask to do. Once that you have done the exercise, please let me know in the chat, and I can continue with the. Well, we can solve the exercise together, and we can continue with the lesson. If you want, in case that you want to copy the vector, please go to the share pad, and you can copy and paste. Okay, so I think we can solve the exercise together and see the solution of the last one. Okay, so grand. So okay, so let's yeah, I need to my studio screen. I was updating the. Give me a second. Okay, so yeah, need to share the. Also, one question: is the audio better than yesterday? I hope so because I didn't hear any since that the cable is better than Wi-Fi. So it should be this one. Okay, what I will do here, I will copy the exercise here. Here to the I'll make this a comment. Well, actually, this is not a comment. So I can. Okay, so let's start. Let's see, using this vector of heights in inches, create a new vector with an as remove. So we execute that line. And now we have this vector that we can, the console, we can see if that, no, it's called height. Okay, so I see that we have a vector. Also, I can check if you remember the str function. It's a vector of our numbers. We have 21 elements, and well, have the first elements there. So here they said I use the function median to calculate the median of the height vector. Okay, so I guess the name of the function should, oh well, yeah, median is in the same. And the problem here, if I use, if I don't remove the elements, I get NA. So the way of is I can use, for instance, is the NA height. So the thing here is saying select the elements that are numbers that are, let's say, defined. So if I do that, I get 64. But I think that the function contains the na.rm. So I can put this to true, and I can get the same solution. So, oops. So I can use either this or this, or well, there are other choices, but up to you. And the last one is use R to figure out how many people in the set are taller than 67 inches. Okay, so we have a height. Height taller than 67. Let's see if that. Okay, if I use that, I get the vector that is on the board. I get 69 and A. That's the thing, because with NA, I don't know number. I don't know if it's like a below 67, above. So R keeps the number and said, okay, this is let's say undefined. Um, this that yeah. Before I suggested the problem is if I use length here again. I'm sorry. Spelling of length is always I get 8, and it's 1, 2, 3, 4, 5, 6. So actually it's a 6 plus the NAs, but I'm not interested in the NAs. So one way of doing that is, let me think. So we can filter the elements, get let's see if that works. We can do this, and okay, so this is one of the solutions that we can use. Also, I think if you check the documentation, first they serve they create a new vector without the NAs and calculate the filter according to the 67 inches and provide. But in case that you don't want to save this in another vector, you can use something like that. Any questions regarding this? Let me check the chat. Also, a comment that in other courses I received the question, when we have a vector, we have seen that we can append elements at the beginning, at the end, but what if I want to insert an element, let's say position 2, position 3? That is a function that is called append, that you can use this function to add elements. We can find them in here in the documentation. Append, you give the vector and you give the value or values that you want to include, and you need to specify the position that is after the length. If you include the elements after a given position. For instance, if I have animals, mouse, rat, dog, cat, and I want to insert I don't know, horse after mouse, I can do let's append animals, horse 1. So let's see if that works. You see the output is mouse, horse, rat, dog, and let's see if I specify position 0. Let's see if that. Okay, yeah, 0 is at the beginning. So if I write animals, you see that the variable animals variable vector hasn't been changed. But if you want to change that, you need to save the output of this function. Now if I print animals, you see that now we have a mouse, horse, rat, dog, and rat. This is in case that we want to include elements in a specific position. Okay, so let's continue. Now, what we will do is we will work with a CSV file. We will upload the CSV file to our playing with that. For that, first we need to download the CSV file. That is a function in R where you can download the things. I will paste it here. This is the command to download the. So if you see, the function is called download and specify the URL, that is this one, and you specify the destination of the file that we will save in our folder data row slash and the name of the function, that is portal data join. So if we execute that, yeah, it's a file of 2.9 megabytes. It's downloaded. If we go to data row, we can find this file that I think if we click, we can view the file. Well, I get a warning that because the file is large, it's 3 megabytes, it will take some time to open. Not sure. Well, let's click in yes. I hope that my computer don't break. Oh, it's not showing. Well, this is the file. As you can see, the first row are the names of the column names, and from the second row we have the values for each observation. And how now we will need, I'm not sure if you have installed it, the library, but well, you will figure out because you will get an error. We need to well, load the library tidyverse. That's one of the good features that I mentioned at the beginning, that are you can use a lot of libraries that offers a lot of features, functionality. So one of the libraries that we will use today is tidyverse. So if we load that library, in case this is not installed, you will get an error, but in case that is installed, you get this output. Actually, tidyverse is itself is a set of libraries. So when you load tidyverse, you load the ggplot2 that tomorrow we will see how to do some plotting. tidyr that also we will use it tomorrow. So you load several libraries. And also you see in conflicts, the thing is there are two functions called filter and lag. And if we use these functions, we will use the functions that are contained in the library deployed, or whatever is pronounced, rather than the functions that are in the stats library. In case that we want to use the functions that are in the thing is, these two libraries contain the same function name. So if you don't specify the library, you will execute by default the functions in this new library. If you want to use the functions that are loaded in the stats library, you need to specify the library. You need to say stats filter. If you use this without specifying, you will use the things deployed or whatever filter. But I don't know. I don't. Oh well, yeah, no. Tomorrow, I think tomorrow we will use we might use a filter. Okay, so I have loaded the library tidyverse. I'm not sure if in case that you get an error, please let me know. And now what I will do is I will create a variable called surveys, and here I will load the CSV. It is important. I remember that I made when you write a read, you get a read.csv. Use that function because if you see on the here, this function belongs to the library utils, but we will not use that library. We want to use the tidyverse library that we have loaded. Rather than a point, is a underscore read CSV, and you see that here we use the libraries red R. Is that different? Why we are using that? I will explain this now. So okay, in this library we have a read CSV, and now we need to specify the where the file is. So it's in data row. The thing, if you start writing and clicking tab, gets the autocomplete. Why we are using this function rather than the other? Because this function loads the class that use the type of variable that use is called table. It's a subset of it's like it's a version of a data frame. Let's say if you use the other function, use another type of variable that is not as efficient as this one. That's why today we are using this. Okay, so let's load this. Control Enter, and the output that I have, we see in the console more than 34,000 rows, 13 columns, and also they tells you the delimiter, that is a comma, and we have also when we load the library, it guesses if it's a character or if it's a double. In this case, double of use a double as a number. So for the columns species ID, sex, species, taxa, plot type, use a character, and for the rest use a double number. Record ID, month, day, year, plot ID, hint, footer, length, and weight. Also, again, when we use and read underscore CSV, the delimiter by default is a comma. That is a function that is read underscore CSV2, that is a semicolon, the delimiter, because it could happen languages, countries, for instance, in Spain, we use a comma rather than a point for a real number. So in that case, the CSV, to separate the values using a comma is not the best, let's say. So we can use a semicolon or we can use the TSV, that is tab separated values, but the thing with tab, I don't know, doesn't look quite so semicolon. If I had to choose, I would and also again, if we go to help and write read underscore CSV, we can get the function and this read delimiter 5 into a table. This is the type of we are talking today about data frames. This is the type that we are using. I mentioned data frames. With data, what is a data frame? Basically, is a table. A table that shows, and we can play around with this table. We will see now all of these features that we can find. There is a function in case that we want to see the beginning of the table. We can use a head and the name of surveys. So if we use that, we get the output is well, it as that is a table. That is we get 6 rows and 13 columns. Well, we can see here the record month, the name of the columns here, also the type for each column, and we get this output. Well, we get also in red the elements that are not defined. Also, I think we can use view surveys. I don't remember now what. Okay. We can see that like it was like a I would say spreadsheet. Also, you can sort by month, by the. So you have like a more a better view of this. Can use filters, so yeah, that are more. We'll close it. So basically, a data frame is a table with a lot of functionality, a lot of features, as you will see. We got okay. Let me write better here in this document. If we use str surveys, tells you more information about the data frame that we are using. So tells you the size, tells you the number of columns that we have, the elements that is numeric, could be a character. So tells you like at the beginning of each one. So gives you more information about the. And in case that you want to get more, I don't know, dimensions, you are not interested in all of these outputs, you can use other functions. You can use dim surveys and gives you a number of rows and number of columns, but also you can get a number row and the number of rows. The number of columns is encol surveys, get a 13. Before we have seen the head of a surveys, so the first 6 rows. You can also see the last 6 rows, is a tail. So you get the end of the table. So you can get the names of the columns, so this is names, surveys. So you get all of these names. So there is a interesting function that is, no, it's a summary. Let's see. Surveys. Summary of surveys tells you for each well, I think in this case is maybe more interesting. Let's say weight will be interesting, or input length. Tells you for instance, let's go for weight. Tells you the minimum, median, the mean, the median, the maximum, the number of elements that are not defined. So for each column tells you the summary of minimum, maximum. For instance, for month, this is a way also to double check if things are okay minus 12. That's fine. 1 is January, 12 is December. Imagine that we have a number that is minus 1 or 13. So we need to find that and clean it or fix it. For day, we have from 1 to 31. Year, we have 77, minimum, maximum 2002. So we can get a lot of info using this summary. And we have load, well, this table that we are using is 3 megabytes. You can see that the quick, but and also you can load tables that are way bigger. Not sure if we do this with using a spreadsheet will take longer. So using R is very good, is way more efficient. We were checking how to index vectors, but also we can do the same with data frames. If I want the first element, again I use a square brackets. If I want the first row, first column, I separated the indices using a comma, and I can get that. So I get the number 1 here. Again, I get the output that I get is a table. In case that I want to get the number itself, I need to use and you see here, you see that the output is different. Here I get a table, so I get again a data frame. But if I use this, I get the element itself. I can get the row, the first row. So I can use use a surveys one, and I don't specify the column. So I get a table of 1 row and 13 columns. And the other way around, I can also, okay, I will copy this here. I can get a column, let's say the first column. So I get again a table of all of rows and 1 column. I can get also a subset specifying only the first 3 columns. Oops. Sorry, the first 3 rows. So I can say surveys 1 column 3 or columns. So you see that the table that they get is 3 rows and 13 columns. And also you can use you can choose I want the column number 1 and number 7. So you have many many options. And now is talking about that is a challenge time. So what I will do is I will share the. Let me. Share the exercise. I think it's this one. So this is the challenge that we will solve now. Again, when you finish, please know in the chat, and we can solve it together. So, do you want more time to solve this, or shall we solve it together? Okay, let's solve it together, because I would like to explain some things before we finish the lesson. Okay, so let me share. Mm, RStudio. I will copy the exercise here. So the first part is create a data frame containing only the data in row 200. So this should be like a surveys 200 segment surveys. Should remember the way of accessing that. So the row 200 is data on row. Columns we will have all. So if I execute that, I see that I have a surveys 200 with one observation of 13 variables. So it tells you notice how one row gives you the number of rows in a data frame, using that number to pull out just that last row. Okay, so there's us that use surveys, and to get the last row, we can use and row surveys. Our columns here, and the output that we get is this one. Let's compare that with the tail surveys. So we see that I'll make this smaller. Yeah, we see that this line is similar to this one, not to say the same. So yeah, it works. And this that create a new data frame, surveys last with the last row. Okay, so we do survey last segment surveys. Use end row to extract the row that is in the middle of the data frame. Okay, so we have a data frame that is okay. They wanted to call it a surveys middle segment, and it's a surveys, and it's end row surveys divided by 2, and I want all columns. So if I execute that, again I got one table of with one observation and 13 variables. Last one, combine and row with the minus notation above to reproduce the behavior of other surveys. keeping just the first row, 6 rows. Okay, so for if we use head surveys, we get the 6 first columns. They tell us to do the same surveys, but using an end row. So okay, the rest is from 7 to end row surveys. If we execute that, we get everything except the first 6 rows. So if we use minus and we surround this by brackets, we execute that, is give me everything except this part. So this part is from row 7 until the end. So we get that output that is similar to the, well, similar, it's the same to this one. So these are the exercises. Let's continue with the next part. The next part, we talk about factors. Factors here is when we are useful to use because if you use factors, some columns gives you a better, gives you a more features. What is a factor? A factor is used when you have a column that contains categorical data. For instance, columns like sex that contains male or female, genus, species, plot type contains a given subset of contains only like some categories. If you use a factor, you will get a better functionality. You can update the data frame and you can change columns that are defined as I don't know, integer, uh, character. You can use factors. How you can do that? Let's create factors. The way to do that is surveys dollar sex. This is also a way to select a column from the surveys if you use the dollar symbol. Assignation factor. This is a function, and here you include the column surveys dollar sex. So now, if we print the summary of surveys, you will see sex. Now you don't see that there is like a for genus, for instance, you get the length, class character, etc. So here you get a better representation of what the content of the column sex. So you get females, you have more than 15, males you have more than 17, and NAs and defines you get almost 2000. So when you do summary, you get a better estimation of. So let's do another example of what a factor could be. So we can create the vector or the factor called sex. That is a factor of this vector that contains male, female, female, male. Oops. So we get a vector of four elements, and we will do a factor. So we have, if we check the memory here, you see that I think if we do strsex, they tell us the structure. So we get a factor with two levels. The first one is female and the second one is male. And we have the contents are 2, 1, 1, 2. Also, this is a way to save memory. Because you have two levels, you can use numbers rather than in case that in this case we have male, female, that is a long character. Using numbers is like a more efficient way of. So we use a structure, but we can use also the function levels, sex. So we have the two elements, female and male, and also we have the number of levels. That we have a 2. We can also the levels, because if you see here, the ordering is according to is alphabetical. So F goes before than M. So you first is female, then male. If for some reason you want to change the order, you can do so. Defining the variable sex again, and you need to do a factor. You define the elements, and also you can define the levels. The levels are equal male, female. When you execute that, if now I use str sex, you will see that now the order change. Now first is a male, female, and rather 2, 1, 1, 2 is a 1, 2, 1, because they use a different ordering. Okay, let's do a small challenge here. So let me share challenges. And we will play with the factors. So the challenge is change the columns taxa and genus on the survey's data frame and use the function that we have learned before to see how many rabbits were observed and how many different genera are in the genus column. Also, because we are close to the finish of this of today's lesson, we can do okay. We can spend these minutes to solve the exercise, or I can give you this challenge as a homework, and tomorrow we can solve the beginning of tomorrow lesson. We can solve the challenge. What do you prefer? Okay, so what we will do is I will copy this exercise in the shared document. I will copy the shared document again here, and tomorrow we will solve it we will solve the exercise. And also, please have a look at the what we have seen today, and in case that you have any questions, we can solve them tomorrow as well. Yeah, we can. I think we can finish for today. Thanks for attending today, and see you tomorrow. Have a nice rest of the day. Bye for now.